In this video, I'm going to show you how to divide by powers of 10. And I have several problems set up here. I'm starting out with 500,000 in each problem, and then I'm increasingly dividing by a larger power of 10. So I start out by dividing by 10 to the first power, then 10 to the second, 10 to the third, 10 to the fourth, and then 10 to the fifth. And you can see that in this pattern, I'm losing a 0 in my quotient every time. And the reason for that is when I'm doing 500,000, 500,000 is really 5 times 10 times 10 times 10 times 10. This big part right here is really 100,000. So I'm really doing 5 times 100,000 right there. When I then divide by a 10 divided by 10 is equal to 1. So it basically just cancels out each of these 10s right there. So I lose a 10 from my 500,000, and that's why I end up with 50,000. And the same thing happens all the way down. In my next example, this one right here, I'm losing 2 10s right here that are canceled out, which is why I only have 3 10s in my quotient. Here I'm losing 3 10s, so it leaves me with only 2. 4 10s, only 1. And this time, in my last problem, I'm losing all 5 10s that I have. All 5 of them are being canceled out, so I'm left with a 5. So if I put 500,000 in the place value chart here, we can look at what's going to happen to our digits as I divide by powers of 10. In my first problem, I did 500,000 divided by 10, and I ended up with 50,000. So to get 50,000, I needed to move my entire 500,000, my entire digits one place to the right. That leaves me with 50,000. This last 0 that's over here is in the tenths place, so I don't even need to have that 0 because it's after the decimal. So this number right here is 50,000 with a decimal and 0 in the tenths place. On my second problem, I divided by 100, which was 10 to the second power. So I divided by 1 2/10, and I ended up with 5,000. Again, now I have 2 digits after the decimal. These 2 digits don't have to be there. They have no value in them. And on my third problem, I started out with 500,000. I divided by 1,000, ended up with 500. So to get to 500, I moved 1, 2, 3 place values to the right. On my fourth problem, I divided by 10,000, ended up with 50. I moved 1, 2, 3, 4 place values to the right. So you can see the pattern that's happening here. Anytime we are dividing by a power of 10, we're moving our digits one place value to the right. Now this has the same effect as moving the decimal point one place value to the left every time I divided by 10. Just keep in mind that decimal points don't move. The decimal point is simply a divider between the whole number of place values and our decimal place values. So let's look at another example. Let's start out with 4,557,624, and let's see what happens when we divide this by 10, by 100, by 1,000, and so on. So I'm going to write that same number in the place value grid, 4,557,624. If I were to divide by 10, I would move my entire number one place value to the right. So I'm going to take my entire number and shift it one place value to the right. So now my number becomes 455,762 and 4 tenths. If you think of this as moving the decimal, my decimal point starts out right there after the ones place on any whole number. So I can take that decimal, and because I'm dividing by 10, I can take this decimal and move it one place value to the left. That is the same effect as moving my digits one place value to the right. So my decimal goes from being right here to being right here. And you can see that matches the answer that I have in the place value chart. So let's look at what happens when I divide by 100 now. So I'm going to start with my original number again, 4,557,624. When I divide by 100, I move my digits 2 place values to the right, 1, 2. This doesn't line up perfectly, but you can see that now I have 2 digits in the decimal place values. So if I again look at my decimal point, and think about my decimal point as being right here. And when I shifted the digits all the way to the right, my number went like this. As I shifted these over, my number went 1, 2 places to the right. So you can see that that decimal, even though it's staying in exactly the same place, 1, 2 to the right, it looks like the decimal is moving to the left. So when you're working this out on paper, you can move the decimal place 1, 2 to the left, knowing that that has the same effect as moving the digits 2 places to the right. This pattern will continue every time I divide by a power of 10. So if I divide by 10 to the third or 1,000, I would move my digits 3 places to the right or move the decimal 3 places to the left, and so on. Let's look at an example with a number that already has decimals in it. Let's look at an example with a number that already has decimal place values. So let's do 726 and 591 thousandths. I'll write that in the place value chart, 726 and 591 thousandths. When you divide by 10, you move each digit 1 place value to the right. So this would be dividing by 10. Instead of 726, my number becomes 72 and 6,591 ten thousandths. Again, if we look at this as moving our decimal, here is the decimal point right here. When I move all of my digits 1 place value to the right, it has the same effect as moving the decimal 1 place value to the left. So let me show you what that would look like. So if I divide it by 10, this is my number, 72 and 6,591 ten thousandths. And as I continue to divide by 10, it appears that my decimal is moving to the left. Even though the decimal is staying the same, the digits are just moving to the right. So every time I divide by 10, you move the digits to the right, which is the same thing as moving your decimal to the left.